My students, in the last class we have studied about the solar collectors, their types, how they are made up of. Now we are going to study the flat plate collectors, their material, how it can be used to change heat energy into the electrical energy or for the hot water or the cold water resources. Now first thing we are going to study is the material for flat plate collectors. The properties of material depends on the following factors mainly. It's one is the thermo-physical properties, second is the physical properties, and third is the environmental properties. In the first, the thermo-physical properties mainly deals with the thermal conductivity and the heat capacity. Physical properties deals with the density, tensile strength and the melting point. Environmental properties mainly deals with moisture penetration, corrosion resistance, degradation due to pollutants and many things. The material for absorber plate should have the following things: the high thermal conductivity. It should have high thermal conductivity, adequate tensile strength. Tensile strength is more important as it should not be cracked due to some pressure or external force. Good corrosion resistant as the material is exposed to the environment, it should be corrosion resistance. The most common material which used is copper, because copper has some properties. What properties? High thermal conductivity, corrosion resistance. These are the properties of copper. So it is being used for making the flat plate collector. Others are aluminium, iron, brass, silver, tin, zinc. We know that the wires of the electric current carriers are made up of aluminium or copper because of the same properties. For insulation purpose, material should have mainly the low thermal conductivity, should be stored at high temperature. Means you have to insulate the heat from exposing. We need the material which is low thermal in conductivity and should be stable at high temperature. Should not change its form when at high temperature. And example of insulator material are crown white wool, grass wool, calcium silicate, cellular foam. These are the examples of insulation material. For cover plate, we use mainly the glass, the transparent plastic. Transparent plastic consists of mainly acyclic polycarbonate or PVF. Material for concentrator. That was for the flat plate collector, and this is for the material for for concentrator. Reflector should have high reflectivity. As we have seen, it used the diffusion energy, means the light from the sun is reflected to the absorber area. So it should have the high reflectivity. Higher the reflectivity, higher it will reflect to the absorber area. So more energy will be collected. Example can be mirror glass, transparent plastic, and many more. Applications of flat plate collector. The application of flat plate collector is as follows. They are mainly water heating, space heating, power generation, mainly used for water heating and space heating. Power generation is mainly in the power heating, mainly concentrated plate collector is used in the water heating. Solar radiation passes through the transparent cover. After this, it strikes on collector plate and converts the radiation energy into the heat. This heat is useful for water heating. Seen from the diagram figure, that the solar radiation strikes on the plate, that is flat plate collector, and this is the flat plate collector, it's written here also, and the part of it is stored in the storage tank, and some part can be directly reused for water heating and for space heating. The storage tank is used so that on a clouding or a no sunlight environment or climate, it can be used in night or at that situation. Space heating. When absorber plate gets heated due to radiation, then heated water in tubes sent to storage tank. Afterwards to heat exchanger through pumps, where we can convert cold air into hot air. Means the seen from the diagram, solar radiation strikes the flat plate collector. It is being stored in the storage tank. This is also a storage tank, but this particular circle denotes the storage tank. This storage tank will be used as a collected energy, will transform into that heat energy, and this heat energy can be used. Cold air, we put up cold air, and this is the heat exchanger. This cold air changes into the hot air and will go to the other pipes. Power generation. For power generation purpose, a turbine is used. Afterwards, a vapor generation plant which heats up water up to the dry vapor condition. Clearly seen from the diagram, the solar radiation strikes the flat plate collector and it is being stored. This is being stored, and this is the main storage area that changes that stored the heat energy, and this heat energy is used for vapor generation. Here the vapor generation is being generation is taken place, and this vapor is helping the turbines to move, and this turbine makes the production of electricity. The rest of the vapor that is being condensed and being used by a pump to regenerate the vapor. That's how the mechanism works. It's a cycle. Vapors turns the turbine, and the vapors will be condensed to form the liquid part, and this liquid will again be converted into the vapor part using this vapor generation segment. Application of concentrating collectors, where we use the concentrating collectors. The concentrating collectors are used there where high temperature is required. As I already said, the flat plate collectors are having a huge area. We have seen in the previous class, is having a high area. It absorbs heat from a high area, but its heat generation is very low, as it is used only the direct sunlight. But in a concentrating collectors, it can be collected from a maximum area, but the heat from that area is focused to an area, to the absorber, fixed area, so that the heat can be generated more. So where high temperature is required, the concentrating collectors are being used, such as in power generation process. They uses only direct beam radiation. Where direct beam are used and this being reflected. So the solar, we got to study the solar thermal power plant. Solar power has low density, that is kilowatt per meter square. Hence the large area on the ground is covered by collectors. The collectors receive energy or heat from the solar rays, and it gives the heat to transport fluid. Solar thermal power generation employs power cycles, which are broadly classified as low, medium and high temperature cycle. This low temperature cycle generally use flat plate collector, so that maximum temperature limited to about 100 degrees Celsius are being used. Medium temperature cycle works at the maximum temperature ranging from 150 degrees Celsius to 300 degrees Celsius. While high temperature cycle works at temperature above 300 degrees Celsius. Basically, in a solar thermal power plant production system, the energy is first collected by using a flat plate collector, a solar pump, or a focusing collector. This mainly energy which is stored, which is being collected from the flat plate collector, is used to increase the internal energy or the temperature of the fluid. When this temperature of the fluid increases, this fluid may be directly used any of the common or known cycles such as Rankine, Brayton or Stirling, or passes through a heat exchanger to heat a secondary fluid. That first primary fluid is being heated up and it uses that fluid to heat the secondary fluid, which is being used in a cycle to produce mechanical power from which electrical power can be easily produced. Now, the solar thermal energy conversion system are classified into following categories of application in order to rise in cost and complexity. The low temperature solar power plant using flat plate collector, mainly that is greater than 100 degrees Celsius. Low temperature solar power plant using solar pumps more than, that is 150 degrees Celsius. Solar, that means from this we can understand flat plate collector are limited to the efficiency of 100 degrees Celsius, but solar pump can be used for low temperature. It is also a low temperature, but for greater than 150 degrees Celsius. For medium temperature solar power plant using focusing collector with a concentrating type of collector, and it varies to 150 degrees Celsius to 300 degrees Celsius. Here high temperature system, when we have to use that high temperature system, that is greater than 300 degrees Celsius, the distributed current system, that is solar farms, are used, or central receiver system power plant is being used. So what happens actually in a plant? So low temperature solar power plant using flat plate collector. What happens when a flat plate collector is used for low temperature generation? In this system, an array of flat plate collector is used to heat the water to about 70 degrees Celsius, and then this heat is used to boil butane in a heat exchanger. The high pressure octane vapors thus obtained runs a butane turbine, which in turn operate a hydraulic pump. The various steps which will be followed in a plant are: step 1, solar thermal collector system collect the heat from the solar radiation and gives it to the heat transport unit. Second step, the heat transfer fluid receives the heat from the collectors and delivers it to the thermal storage tank or the boiler system generator. First, the collector collects the heat from the solar radiation, and the heat is transported to the other unit. The heat which is that is heat is transferred through fluid, is that is from the collector. It will be sent to the thermal storage tank or the boiler system generator. Now the step 3, the thermal storage system stores heat for a few hours, that it uses for a few hours to release it during the cloudy season or cloudy hours or at night time. Step 4, the thermal electronic conversion system receives thermal energy and drives steam turbine generator or gas turbine generator. And finally, the step 5, it involves the hot water and the steam transport to heat power plant to get additional electrical energy. Besides the solar power plant, the solar plate collectors, the storage, and various things we have termed before, few other subsystems are being used. Solar thermal collector or the reflector, where the heat energy is collected and is reflected to a unit. Heat transport fluid system, the fluid is very necessary, it absorbs the heat and this heat is sent to the other fluid for power generation. Thermal storage system, the heat is being stored to a system, that is the thermal storage system, thermal receiver. One thermal storage system delivers the heat to the other thermal state system, and it is called the thermal receiver. Heat exchanger, it converts the heat from to make vapor generation or for air space generation or many other uses. Distributed system for hot water, steam, this is also being used. Solar thermal electric power plant, it's a whole solar thermal electric power plant. Electrical substation and distribution center, this the energy is converted from the heat energy and it is converted to the electrical energy. It should be delivered, it should be transferred to some lower substation where this energy is distributed to the use. This is the main diagram of a solar power plant. It is the solar thermal collector. It receives collect energy from the sun's light, and this is the thermal storage. This is the thermal boiler. Means the energy is which is being connected is transferred to the receiver boiler, and this receiver boiler stored to the thermal storage, where it can be used for hot water, hot air or steam, and for process district heating. Many or other aspects are also there, and this energy is used for gas turbine combined cycle pumps, steam power plants, and these power plants will generate electricity, and it's being 3 AC grid for energy supply. This is the wiring system which is being used to transfer the electrical energy to the subsystems and being transferred to the users. Thanks for today. We have studied the solar power plant. Rest we will go to the next unit, that is geothermal energy, and thank you.